Okay, hello everyone. I hope you're having a nice day. This is our first video for our unit on forces, and the things that we're going to be talking about today are Newton's first law, gravitational force, normal force, friction force, and Newton's second law. Okay, so let's get going. Just really quickly before we get going, in your graphic organizer, it has it says what is an unopposed force. I want you to cross that off, so delete that unopposed force, and I want you to put in gravitational force. All right, so we're gonna, instead of talking about unopposed forces, we're gonna talk about gravitational forces. Okay. Um, so, just to quickly review from our PhET simulation, hopefully these are some of the things that you took from that PhET simulation. So, a net force is when forces are unbalanced, right? So if the force of friction is smaller than the amount that you're pushing, you have a net force, okay? And then also if there is a net force, then that also means that there is going to be an acceleration. Okay, so whenever there is a net force, there is acceleration. Whenever there is acceleration, there is a net force. Those two things go hand in hand, and we'll see why that is very soon. And then if there's no net force on an object, it is either going to be the object is not moving at all, right? Or it is traveling at a constant velocity. All right, so if something's moving but it's traveling at a constant velocity, that means there is no net force. And so I'll show you a little bit more about why that is. So Newton's first law of motion. So an object in motion stays in motion. An object at rest stays at rest unless acted upon by a net force. Okay, so this is pretty weird because it seems like it makes sense that if an object is moving, then there is a net force, but that's actually not the case. So if you look here, these people are in space, they're in the space station. So what's happening is you see he just pushes the bag and it just continues to travel, right? And it's traveling at a constant velocity. So if he was outside of the spacecraft and he pushed that lady, she would continue to travel at that same velocity for the rest of time, right? Unless there's a net force, like she runs into a meteor or something like that, right? So an object keeps on, it wants to keep doing what it's already doing. So if an object's not moving, it's going to keep not moving unless it's acted upon by a net force. Okay, so that's Newton's first law. And in space, it's a little easier to imagine, right? Because something that's in space and is traveling at constant speed, it's going to just keep going at constant speed forever and ever and ever because there's not like air resistance or gravity to stop you. Okay, so the next one, gravitational force. So gravity is pretty fascinating. It's one of the four fundamental forces of nature. Trying to explain what gravity really is pretty complicated, but all that we really need to know right now is that it's a force that exists between all things that have a mass. So there's gravity between, right now, my computer and me. There's gravity between the tree outside and myself, right? And so that always exists between all objects. There is a force of gravity, but really what the most important characteristics of gravity are that it's related to distance and mass. So obviously the most massive thing in our lives is the Earth, and that's where all of the gravity that we experience comes from the Earth. That even though there's gravity between me and my computer, it's not affecting how I am interacting. The gravity, the force is so small that you don't notice it because the Earth is so much more massive than my computer is, right? So if you have a really huge object and if you're really close to that object, then the more gravity you experience, right? So if there's a black hole, and you get really close to it, then you're going to experience more and more gravity the closer that you get to that black hole. Okay? And so we're always experiencing gravity. Right now it's pushing down on me. If I were to jump into the air, it would push me back down, like this guy right here. He jumps, and that's gravity, right? And that's a force, and he's accelerating. He has a net force, and it's going down, and he's accelerating down. Okay? So it kind of looks like this picture right there. That guy is jumping, he's accelerating down with the force of gravity. Okay? So now you're like, well, okay, if we're always experiencing the force of gravity, and that's a net force, then why aren't we always falling down? Well, it's because we have something called the normal force. Okay, the gravity is always pushing us down constantly, but we're not experiencing a net force from gravity because we have the normal force. And the normal force is a force like I'm sitting in a chair right now, the force of the chair pushing up against gravity, right? And so this force of gravity is canceled out by the normal force, and so there's no net force on me. The forces are balanced, right? And the forces are balanced, and we know that because there's no net force because I'm not accelerating. Okay, hopefully that makes sense. Okay, so the normal force is just the force that opposes like the force of gravity. All right. Friction. Um, Friction is the force that opposes movement. So whatever, if I'm running to the left, friction's going to be going to the right. If I'm running to the right, friction's to the left. And you know, there's friction with air molecules. There's friction with the ground. Especially here on Earth, there's all kinds of things that cause friction. In space, it's not so much, but I think we have a good idea pretty much of what friction is. But it's the force that opposes movement. It goes in the opposite direction of movement. Okay, now we're going to talk about Newton's second law, and it's really simple, and it makes good sense because we already know that force and acceleration are related to each other. So Newton's second law is just a definition of force, and it says that force is equal to mass times acceleration. So if I want to calculate a force, I take the mass of the object and how much is accelerating, and that's how much the force is. Okay? And you can see that if there's force, then there's acceleration. If there's acceleration, there's force. And so this equation shows us what we already knew from the PhET simulation, that if there is a net force, then there is acceleration. Okay? And then we have a force triangle. So force, mass times acceleration, acceleration, force divided by mass, mass, force divided by acceleration. Maybe write this down into your notebook or into your graphic organizer. Okay. I'm gonna check these for the grade, so make sure that you do them and come with questions on Wednesday or Tuesday, because on Tuesday what we'll be doing is we'll do like the stations activity where there will be the different stations. You'll go from station to station. You'll have to answer problems that are related to your graphic organizer. So, all right, have a lovely rest of your day, and yep, that is all.